So now I'm going to test this automatic power factor correction with the harmonic mitigation. So this is the transformer which is powering up the complete project. Let me tell you about the component, right? So this is 230 volt AC line which you will give to this transformer, and from here it will be distributed throughout the project, right? So this is the transformer 0 to 12 volt, right? 0 12 means it's 12 volt transformer, and this is the power supply which will convert into 5 volt, and there is another 7805 voltage regulator as well. So we are using two because we are using 8 relays over here, right? Basically 7 relay, 1 relay is spare. So these 4 relay, right, is basically activating these high industrial capacitor bank, right? These are the high power capacitor bank. So 4 relay are connected for these capacitor bank, and these 3 relay, 1 relay is spare, this relay is spare, and these 3 relay 1 2 3, they are for the specific purpose. Let me tell you, if I talk about this first relay, it is used to select the resistive or inductive load, or you can say capacitive and inductive load, because it have induction as well. So this is your capacitive load, and this is inductive load. It will be selected with the help of this first relay. The second relay will add the harmonic distortion hardware, means non-linear load. So this is the non-linear load, this if I talk about, and you can select this load with the help of this toggle. This is the second toggle. With the help of this you can select this harmonic noise, or you can say THD, total harmonic distortion hardware. So it is a non-linear load, and it will deform the waveform, right? So you can select with this hardware. So this hardware is basically selected with the help of this second relay. Now this third relay over here is used to control this inductor filter. So if this inductor filter will be added, then total harmonic distortion or THD will be improved, right? And these 4 capacitor bank will improve the power factor as well, and THD as well. And this is the hardware selection button. This is toggle 1, this is toggle 2. Toggle 1 is for selection of inductive load and capacitive load, right? And this is the current transformer which is used for zero sensing circuit, right? And this is Arduino Uno which is processing all the information. This is LCD which is 20x4 LCD, big size LCD, which will display all the information in the project. Again, this power supply, this rectifier circuit, you can see that over here we are using, because directly we are converting 12 volt AC from this transformer into DC. So this is 78051 and 2. So we are using 2 7805 because we need 2 relay boards. So one 7805 is heating a lot. That's why we are using 2, 1 and 2. And always remember, don't make this project on for a very long period of time, because 7805 get heated up, and there is a danger of the destruction of 7805. So use it when you want to show the demo. Now let me just provide the demo. So this is 230 volt. Now it's added message on the LCD, automatic power factor correction and mitigation. So power factor correction system recalibrate, please wait. Okay, so it's added a capacitor and 0.90 total distortion calculating. It is calculating the distortion as well. Now it's 13%. Power factor calculating, it's calculating because these tuk sound is coming from the relay, because relays are being added. Now power factor is 1, harmonic distortion is 3.9%, right? So you can see that 2 capacitors are ready. These are the LED. So this is for inductive load. Now let me just change it to the capacitive load. Now it's changed to the capacitive load. Power factor calculating, total harmonic calculating, right? It's 0.63 and harmonic distortion 27.3%. Let me wait, it will add the hardware. Now you can see that inductor is added. This inductor is already added, and first capacitor bank is added. It is calculating the power factor. Second capacitor bank is added, improved a little bit but not very much. Now third capacitor bank is also added. Distortion is still calculating. Okay, now power factor is 0.97, 6.9% after adding all the 4 capacitors and after adding inductor as well. So these 3 LED are, first LED is for the capacitive or inductive load, second LED is that you have selected this THD, right? THD means total distortion harmonic noise hardware, right? And the third indicator is for this inductor. So this inductor, don't touch it with your wire, because I have otherwise it might give you a very strong shock, because 230 volt is going on over here. This is in the series of the line, right? Now let me off the mitigation system recalibrating, because mitigation is off, so this should be off. Now you can see that this inductor is also off, and this hardware is also off, which is controlled from this second relay and the third relay. Now you can see that one capacitor bank is added. Now 2 capacitor bank is added. Okay, power factor is 0.97. Total distortion off. You can see that total harmonic distortion is off now. So this is how this automatic power factor correction with harmonic noise mitigation hardware is working. So it's a very complex project, because troubleshooting is very complex in this project, because you have to continuously code and improve it, right? So this is how it's working. Thank you.